In this lecture, we are going to see how to use a circuit simulator known as TinkerCad. So this TinkerCad is developed by AutoCAD or Autodesk, and in this circuit simulator you are able to simulate normal circuits as well as Arduino based circuits. So here I am going to draw a small Arduino based LED blinking circuit and we will see how to simulate it. So first of all, you need to log on to tinkercad.com. If you are not having an ID there or login there, you need to create a login using your email ID and other things. And then you need to log into the tinkercad.com. So you will be getting a screen like this. If you are a new user, you won't be having these examples here or the circuits here. So for creating a new circuit, you can click on this create new circuit button. So when you are clicking on this create new circuit button, you will be getting another workspace where you are going to create a circuit. And here you are able to connect LED, switch, potentiometer, motors, etc. Most of the components you will be able to simulate using this TinkerCAD, then EEPROM, LCD, all those things you are able to use it for the circuit, right? So this is your workspace. Then first of all you need to add your Arduino to this workspace. So for that you can see here components selection box is there. Click on this. Here you can see basic components and there is another all components listing is there. And if you want to build some circuits or if you want to see some circuits already implemented, you can click on the starters and you can click on Arduino. You will get all the basic files which is already done here as an example. But now I am going to create my own circuit. So for that you can click on this components all. So all the components will be showing here in the list. You can see potentiometer, switch, LED, LDR, ultrasonic, PIR, all the most keypad, LCD, etc. Most of the components which can be interfaced with Arduino is available here. Again you can scroll down and at the last you can see the microcontrollers. So here I am going to use Arduino. So click on Arduino, then move the cursor to a workspace. So you will be getting an Arduino window like this, right? So I am going to do a basic LED blinking program. So when you are adding the Arduino itself, the basic LED blinking program is already inbuilt in this. So how will you take that? Here you can see a code button, toggle code editor button is there. Click on that. So now in the using this IDE, you can create programs using the blocks or block programming method can be used like this. So here if you are using block programming, you will be using the blocks like this. Set built-in LED to high. That means LED will be on. Wait for 1 second means LED will be on. Then it will wait for 1 second. LED will be off. Then it will again wait for 1 second. So this is an LED blinking program which is already done using the blocks method. But here I am going to do here I am going to write the program in the native programming method itself. So you can click on this blocks listed down, select text. So it will be asking whether you need to go out of blocks editor. You can click on continue. So now you can see the actual Arduino program for blinking of an LED. Pin mode 13, output. What does it mean? Pin mode is used for configuring a pin as output or input. If you want to configure a pin as output, when will you configure a pin as output? Whenever you are going to connect an LED. And when you want to configure it as input, when you are going to connect it as switch. So now you are going to connect an LED to pin number 13. So you need to configure pin number 13 as output. By default, pin number 13 is connected to onboard LED. Here in the circuit you can see an LED written with L. This is onboard LED. It is already connected to pin number 13. That is why in the example program pin number 13 is used. So pin mode 13, output means you are making pin number 13 as output. It should be in capitals, and in pin mode the second word mode M should be capital. So you are writing this statement inside setup. That means this function will be executing only once. So this is known as a configuration step. You need to execute it only once. Then in the void loop part, whatever you are writing in void loop, it will be running infinitely. So here I am writing the code for blinking of an LED. So how will you blink an LED? You need to make the LED on, then you need to wait for some second, then you need to wait the LED off, then again you need to wait for some second. Why this delay in or why you are waiting for some second means, if you are directly writing, if you are making LED on and off in two consecutive statements, the rate at which the program is running will be very high. Around 11 megahertz your controller will be running. So in 1 by 1 11 megahertz, that much time will be taken for one instruction to execute 1 by 11 megahertz. So it will be some point something millisecond. That means in point something millisecond LED will be on. In the next point something millisecond LED will be off. Right? So it will be on for very small millisecond and it will be on for very small millisecond. So what is the problem is that my eyes will not be able to distinguish the on and off state. Why? Because if you want to see an on state, it should stay in my eyes for at least half a second. But here you are making it on in 0.0 something millisecond and you are making it off again in point something millisecond. So you will not be able to distinguish on and off state. That is why you need to make it on, you need to wait for some time, you need to make it off, again you need to wait for some time. Right? So for making an LED on, you are using a function known as digital write. Digital write parameter will be pin number and what you are going to write. Whether you are writing logic 1, that means high. If you want to write logic 0, it will be low. Right? So if you are using digital write 13 comma high means to pin number 13 you are writing a logic 1. That means in that pin you are generating a 5 volt VCC signal. So when you are using digital write 1 or high means you will be generating a VCC there. So if you are connecting an LED at that pin, that 5 volt will be connected through an LED to a through a resistance to that LED. So the LED will be on. Similarly, if you want to make the LED off, what you will do? You will use digital write 13 comma low. Low means you are writing 0 to that LED. So that pin will be generating 0 volt and the LED will be off. Right? Again in digital write the second word first letter, that is W, should be capital and high and low also should be capital. So by using digital write 13 comma high, what does it mean? You are making the LED on connected to pin number 13, then you are giving delay 1000 means for 1000 millisecond, that is 1 second you are waiting, then you are writing digital write 13 comma low. Low means you are writing 0 to that pin. So the LED will be off and again for that also you are giving a delay. So for both the states you need to give some delay. Otherwise the corresponding state will not be able to see. That is why you are giving delay for both the states. And this program will be continuously running. So we need to run this program and see. So for that you can click on start simulation and you can toggle this code window. So now you can see the LED here. That LED is getting on and off. You can see this LED, orange LED getting on and off in 1 second. So this is how you are implementing an LED blinking program using Arduino in TinkerCad. Thank you.